Hi folks, today we're going to take a look at factoring trinomials of the form x squared plus bx plus c. In other words, trinomials with a leading coefficient of 1, meaning that the coefficient in front of the x squared is equal to 1. Before we actually get to that though, I'd like to give some motivation as to why we're even bothering to do this. And we're going to take a step back and look at equations that have x squareds in them. So let's say we have x squared minus 4 equals 0. We could easily solve that using opposite operations. So just bring the negative 4 to the other side, then take the square root, and we get positive or negative square root of 4. In other words, our answer is just plus or minus 2. And we had slightly more complex versions of this. Say we have 2 times x minus 4 squared minus 32 equals 0. Again, we can solve this using opposite operations. So just do what we normally would have done. Take the 32 to the other side, then take care of the multiplication. So x minus 4 squared equals 16. Then take the square root of both sides. Again, plus or minus 4. And now we have that x is either 4 plus 4 or negative 4 plus 4. So in other words, we have two possible solutions, as we did before, of 8 or 0. Problem comes when we've got something like x squared minus 6x equals 0. In this case here, there's no way to isolate for the x, at least not easily. We actually will see that we can do it, but we'll need some more sophisticated algebra to do that. But for now, I'd like us to think about, I think, a pretty straightforward idea is if I take the product of two numbers and that product is equal to 0, well, the only possible solutions here are that either a is 0 or b is 0. It's the only way for this product to be equal to 0. Now let's see how this relates to the example that we were looking at here. So no way to isolate the x easily, but one thing we can do is we can factor out that common factor of x, and we're left with x times x minus 6 equals 0. And look what we have. We have the product of two numbers, because these expressions in the end both represent numbers, equaling 0. So similar to what we saw before, the only way for this to happen is if either the first expression is equal to 0 or the second expression, x minus 6, is equal to 0. In other words, x equaling 6. Okay, so let's see that these do in fact solve the equation. So 0 squared minus 6 times 0, definitely equal to 0. And let's check out this one here. Well, 6 squared is 36, minus 6 times 6 is 36. 36 minus 36 is indeed 0. So the reason why we want to factor out this expression is so that we can write it as the product of two simpler expressions. And if we're ever solving an equation, it gives us a way to find the solutions when we can't necessarily isolate the variable directly. So let's take a look at this. So I'm going to start, in order to come up with a rule, we always want to start with the most general of examples. Okay, and I'm going to go backwards. Let's say I have something that's already factored. Say I have x plus m times x plus n. This is what I'd like to get to. So let's see what happens when we multiply these out. So let's FOIL it. X times x, x squared. Then we have plus nx plus mx plus m times n. And what we see here, as we expect, we always have two terms that are like terms, and let's bring them together. So we have x squared plus, now since the order of multiplication order of addition doesn't matter here, I'll write that as m plus n. Since we know that when we're adding like terms, we're only adding the coefficients, the variable part does not change. And of course up here, that should have been mn. So plus mn. So if we're going to have a factored form for this trinomial, we see that the middle term is going to have a coefficient of m plus n, meaning the sum of the two second numbers in the binomials. And the last term is going to be m times n. In other words, the product of the two numbers in the binomials. Okay, so this now gives us a method to factor these expressions. So let's say we look at example 1, and I take a look at x squared plus 3x minus 40. Okay, so in other words, I need to find two numbers that multiply to negative 40 and that add up to 3. So this is where it's usually easier, or in fact I would say always easier, to think about the factors of a number as opposed to the numbers that add up to something, in this case 3. A lot more options here than there are there. Because when you think of the factors of 40, you've got, well, 1 and 40. There's no way those two numbers will ever add up to 3, so then you just keep going. 2 and 20. No, not going to work. Okay, so 4 and 10. No, still not going to work. Then you get to 8 and 5, and you realize that, well, with 8 and 5, you could conceivably end up with 3. So 8 and 5. Now, since the product is negative 40, you know, one will be positive and one will be negative. So you just have to consider, will be negative 8 and positive 5, or 8 and negative 5. And that's where the middle term comes into play, which is going to give us positive 3. So that'll be with 8 being positive and 5 being negative. So now we look at our original expression here, and so we can say that this will factor into x plus 8 times x minus 5, because it's x plus negative 5, so x minus 5. And there we go. We've managed to write this second degree polynomial as the product of two first degree polynomials. Right, and let's just check it just to be sure. So x times x squared, negative 5x plus 8x is positive 3x, and then 8 times negative 5 is negative 40. So these two expressions indeed are the same. So let's just take a look at a second example just to make sure we got this, and we'll take a look at x squared minus 6x minus 16. So again, we're looking for two numbers that multiply to negative 16 and add up to negative 6. So the first ones that come to mind, well, 4 and 4, but 4 and 4 certainly isn't going to result in a negative 6. But if we take 8 and 2, that's got more promise. So 8 and 2. So the question is, since this is negative 16, one of these is going to be negative. Which one is it? That's when we look again at our middle term, and we realize that if we take negative 8 plus 2, we'll get negative 6. In other words, our factorization is going to be x minus 8 times x plus 2. Let's give a quick check. X squared, 2x minus 8x, negative 6x. Then negative 8 times positive 2 is negative 16. So we have the right answer. So there you have it, factoring trinomials with a coefficient of 1. Now keep in mind that this all was dependent on actually being able to find these two numbers. If we, as a last example, take a look at x squared plus 7x plus 24. Well, let's take a look at all our factors of 24. So 1 and 24 won't help us get to 7. 2 and 12, again, won't help us get to 7. 3 and 8 still won't work. 4 and 6, not going to happen. So one thing to keep in mind is that trinomials can't always factor into the product of two binomials. Okay? So the trick is always check your factors of the last number and see if those factors can somehow add up to give you the middle coefficient.